All right, cool. We have a lot to talk about, so I'm not going to waste time and just jump right into it. So today we're going to be talking about something called Chassis, and that deals with entities, events, and change management. So really quick, a little bit about Daniel and I. My name is Chad Sanderson. I run the product team for data platform at Convoy, and Daniel is one of the lead engineers on the data platform team. So a little bit on Convoy before we jump into the technical stuff. Convoy is a digital freight network. It was founded in 2015. Right now, it's worth about $2.75 billion based out of Seattle. It is a two-sided marketplace with shippers on one side of the marketplace and carriers or truckers on the other side of the marketplace. We add machine learning and artificial intelligence on top of that framework in order to price, batch, and group loads together. So again, just some context about what the data platform actually is at Convoy. This graph on the right shows all the products and services that we own. We're about 20, a group of around 20 software engineers, data engineers, product managers, and EMs. We have billions of rows of data, which for a company of our size is quite small. But our data is extremely complex, and we have a lot of very complex use cases that we deal with on a regular basis. Our team owns the end-to-end data technology stack, and so that means everything from the source data all the way up to the BI layer, the experimentation, and machine learning layer as well. And as you can see, there's quite a lot of SaaS, open source, and homegrown solutions there. Okay, so let's jump into the core of the problems here and what we're mainly going to be talking about today, which is issues with big data. So one of the first problems and one of the largest problems that we have at Convoy is that we expose our database internals in the data warehouse, but there's not a real contract. We do all this work to basically abstract away implementation details behind APIs, and then we just dump our database content into Snowflake. And that results in a really brittle data warehouse where small changes can easily break downstream consumers. Engineers don't have a lot of visibility into actually who's consuming their data, and adds a ton of complexity into our production systems as well. Our production data model also doesn't represent the real world. So this is a result of basically 5 or 6 years of locally optimal changes. So engineers moving really quickly, building out new services, and not treating data as a first-class citizen. And once again, changes to a service's internal database schema have a really big blast radius, so this is quite problematic. And of course, very hard to change. Our Postgres databases are really great at storing the current state of the world, but not so good about telling us what actually happened in the past. There's a lot of mutable rows, meaning that we overwrite values. And we've tried a bunch of approaches to solve this. Everything from like row versioning to using Mixpanel in ways it really wasn't intended to be used, which is quite expensive and slow. And it becomes really hard to answer questions that are conceptually very simple, like how many times did this thing happen? Or how did a particular shipment end up in this state? This is a really important problem for us to solve because there are entire teams at Convoy dedicated exclusively to answering that latter question there. They've implemented a lot of custom logic to figure out how to do this themselves. So in addition to the big data problems, we also have a bunch of big data management problems that are a result of the big data problem. So for example, Snowflake is really messy and difficult to navigate for basically everyone, and that causes a bunch of challenges. We've implemented tools like dbt. We're really heavy dbt users, and so we want to democratize model development. But because our data warehouse is so messy, the mental friction of figuring out where to find things in Snowflake and reuse them is actually lower than the cost of people just building their own models over and over again, which leads to a lot of duplication and makes sort of point number one even worse. We use data discovery tools like Amundsen to help here, but personally, I consider these more like Band-Aids for gunshot wounds. We're making the problem a little bit better, but the fundamental issue still remains. When schemas change, we don't have any good communication channels here besides Slack, and that's pretty spotty. People will miss updates. And SQL queries that were written near Convoy's very early days are total black boxes. There's a lot of institutional knowledge there. They're very brittle. Oftentimes the person who created them has moved on, but these are still, business critical. So we did a lot of research on this subject. We took about a quarter in early 2021 to take a first principles approach and figure out how we wanted to solve it. And there's a few main takeaways. The first one is we need to start treating our data like a public-facing API. So as Convoy is growing, it's actually no longer feasible to rely on this sort of off-the-books agreement between stakeholders. The second is we need a good mechanism for recording rich semantic events. And by semantic event, I mean some real world action and not just like a CRUD event. We don't have a very good way, or at least when we produce this, we didn't have a good way of doing it. And that leads to extremely complex queries to infer things that may have happened in the past. The key point is this one. If we can abstract away our analytics data model from our production services, then we're going to radically increase both our engineering and data science innovation velocity. Engineers don't have to worry so much about what's going on downstream, and data scientists don't have to worry so much about this, inferring and interpreting really nasty nested JSON that gets passed from Postgres. So this sort of framework would really simplify a lot of the data science workflow as well. So when I talk about events, especially semantic events, I want to clarify exactly what that means and why events are valuable. So initially, when we think about where we are going to apply events, the focus is mainly on the data warehouse. But there's a ton of other use cases, including service-to-service communication, but we're not quite there yet. We're using the data science initiative as the main push to adopt this type of work. One of those use cases is machine learning, feature computation. So this would allow us to compute point-in-time feature values for training, metrics, which we're going to talk about a little bit later, but it will radically simplify metric definitions, audit logs, and entity histories, so you can figure out what actually happened to in history over some period of time. There's a lot of other things you can do here, like emit events to a Dynamo database for fast lookup, as an example. And then it also facilitates stream processing across, Spark, Flink, KSQL, things like that. So I wanted to add a really quick example to illustrate what I was talking about on the institutional knowledge of a metric. What you can see on the left here is a BI model that we ran to produce a metric called Accept Now. That's because we weren't directly emitting any sort of Accept Now event. So there's a lot of complex inference logic happening here. We're also, sort of calling out to a bunch of other BI tables, and none of that's captured. So this query is actually a lot longer than it looks. There's some fuzzy matching going on based on date times. It's really, really complicated. And you can see on the right, when we actually have an event called the Accept Now event, this becomes so much more simpler. And data scientists don't really want to be focused on doing the left. And yet at Convoy, this is something that they spend an enormous amount of their time on. There's not really great monitoring. There's not really great documentation. Ownership falls away, like I said. So this just makes the world a lot nicer for everybody. So the other stage of this project that we focused on was something called the ERD. And this is an abstraction of Convoy's data model. And what that means is we want to define the state of the world that helps data scientists and analysts more easily use these events in machine learning models and reports. And it doesn't necessarily need to map one-to-one to our production data model in Postgres. So that gives data scientists the freedom to define the things that they would use in the ideal world. So if we could go back in time to the inception of Convoy and see the future and say, what should our data model look like, knowing that we're going to have all these products coming in and all of these services, what's the stuff that we would actually care about collecting? And it's made up of sort of three important pieces. The first is this concept of entities. So a carrier could be an entity or an offer or a facility. It's basically a independent business unit. Then there are relationships, which is how entities interact with each other. So an appointment is scheduled at a facility. And then you have events. And events are sort of discrete interactions between entities. So we actually created this over a period of 2 quarters with input from basically everybody at Convoy. This was all the data scientists, the analysts, the entire data team, product managers, engineers, and I realized I should be scrolling through this. And then also even business folks like operations, finance, things like that as well. So we have these three very large projects going on consecutively, one of which is the ERD for entity and event documentation, which helps us understand how the business works. Then there's a unified events framework. And this is the mechanism for actually emitting that structured event data to Kafka. So it's just an SDK. Then we have the data warehouse 2.0, and this is for integrating all of this incoming events data. All of these things together represent what we call the events-driven architecture migration. So obviously, if our services aren't like consuming these events, you can't really call it a full events-driven architecture, but that is in the plan, and this is how we refer to it internally. So now what I'm going to do is pass it off to Daniel, and he's going to talk about a really interesting part, another big piece of this project.
Thanks, Chad. So yeah, so we were, Chad kind of introed all of these problems that we're having, and we wanted to come up with some sort of solution to help us with this. And our solution that we came up is this internal tool we're calling Chassis. So in looking at some of these challenges at a high level, the first of which is change management. So like, how will the modifications happen to the ERD and to events? We have a tremendous, as Chad mentioned, it took 2 quarters to basically compile this ERD together. How do we make sure that when someone wants to go update it, that is done in kind of a easy manner, so we're not just combing through endless Google Sheets day after day? Also, things like who is responsible for making sure that the definitions of these things is kept up to date and accurate, how will people be kept informed, etc. The second big problem that we ran into is that there are a lot of different systems that we need to coordinate across. So if we define something in the ERD, ideally we want it reflected back into the unified events framework, and also then have it kind of represented in the data warehouse. And then the third one is discovery. So how do we know what events already exist? What data are available for those events? And how do these events kind of relate to these entities? So the goals in formulating solution were basically create a single source of truth for these entity and event definitions. We also want to standardize how we make changes to this entity and events, and also make it accessible so that anyone at Convoy can make changes. We talked about how we got input, not just from software engineers and data scientists, but people on operations, in finance, PMs, etc. And then third, because this process is so complex, we want to automate as much of it as possible to reduce errors. So what did we come up with? What is Chassis? So Chassis serves 2 core purposes. It is the source of truth. It is the repository for all of these definitions and events, and it is a change management platform. So it seeks to provide a super easy way for people to make changes to the ERD and the events framework. So for change management, like I said, anybody at Convoy can make changes to these entities' events. Each entity and event has an owning team, and also anybody can sign up to be a reviewer if they are a relevant stakeholder. So if you have a content expert in kind of bidding behavior, but they are not necessarily on the team that owns the bid event, they can sign up to basically be a reviewer and review any changes that are made to that event. Once approved, engineers can then take the definition defined in Chassis and incorporate that data using the unified events framework library. Automation is key here, and it provides basically a way to keep multiple systems in sync and monitors for any discrepancies between all of those systems. And at its core, it puts the power to keep definitions in the hands of users as opposed to in like a small group of people who have to make a lot of manual changes. So in terms of where it fits in, we talked about the 3 big projects. Chassis is basically the glue in the middle here. It syncs all of these things together and basically automates changes across all of these different projects. So why did we come up with this solution? Why did we build it ourselves? So when we were talking to other companies who were transitioning or who had transitioned to event-driven architectures, they talked a lot about the pain points around management and discovery. And so when they were talking about like what we want Chassis to do, they confirmed that like an easy change management system and data discovery would solve a lot of the problems. And we drew inspiration from really good tools like Amundsen, like GitHub, to incorporate kind of the knowledge of what is so good about those tools and how we can apply that to the specific problem that we're solving here. So in terms of automation, we do automation on the validation of production code against event schemas. So as someone is adding events to production services to instrument those events, we do checks to make sure that the data that they are providing to emit in these events matches up with the schemas. We are also basically taking responsibility for updating the data warehouse tables based off of these new definitions. And updating documentation in Amundsen to reflect those changes, and also setting up data monitors on those data to make sure everything is kept in sync. So this is a kind of 9-step workflow of kind of how people normally work. We have people define the data, get approval, update the service, update DBT, make changes in the warehouse, update the documentation, notify parties, set up monitoring, et cetera. And this whole process in practice takes a lot of time. It takes usually at least a week or so. But with Chassis and the Unified Events Framework, we're basically able to automate the last 6 steps of this process. So we have, you still need to define something, but it's defined in a very clear UI. The approval is streamlined through Chassis. And then engineers just need to go update the service, but everything downstream of that is taken care of by Chassis. So now I'm going to turn it back over to Chad, who's going to walk through a couple of the screenshots of what we've built so far.
Cool. Thanks, Daniel. So I'm going to take you through that UI that Daniel was talking about now. So when we think about where a workflow would start in Chassis, there's a couple different entry points. One is all of this data, the entity data, the event data, and the relationships is represented in a graph. And so we want to make sure that it is discoverable through a graph, and that graph has a good user experience. So through the graph page, people can search for entities, events, or relationships as they please, and they can understand how those entities and events then relate to each other. Another entry point is you can also just search for specific entities or events or relationships directly, or see the ones that were recently modified. Once you choose an entity or event to understand, so this is an example of a shipment entity, we create an abstraction on top of GitHub. And the reason that we did that is because we felt that GitHub was not the right level of ownership for many of the stakeholders for different data consumers in the business. So maybe for data scientists, it could work, but oftentimes for folks that really only know SQL, like certain levels of analysts, it really doesn't. For product managers, it really doesn't. And then certainly for more business folks who also care about these types of things, like on the ops and sales side, it doesn't work at all. So we wanted to abstract that and provide more of a semantic layer where changes to that semantic layer could still be reviewed and approved in the same way a code-based PR would. So you can watch or add yourself as a reviewer to any entity or an event. You can add new events that are related to a particular entity. You can define relationships or even connect those entities to specific tables in the data warehouse for discovery. Then you have the process of actually creating a new change set. And this is the brand new workflow that we're really excited about getting the team to begin implementing. During the process of creating a new feature, while that's happening, we want data scientists and product managers and engineers to collaborate on what is the data I need, what are the new events and entities that I need. They will create those events and entities within Chassis and define all the properties, aka what the schema of that event is actually going to look like. Now, we don't have this. It currently hasn't been, it's on the backlog for some time in 2022. But in order to make Chassis the true source of truth, once somebody creates a event within this framework, we actually want to produce the TypeScript code that then gets used to implement the event in the client side, the SDK for streaming the event to the data warehouse. So the point of this, and I think the takeaway is that we really want to consider data as code. That's something that a lot of people have talked about for a very long time. I think that that's a combination of not just making sure that you can get the data that you want easily, but also making sure that there's a really good process for reviewing changes to the data, making sure that it has great monitoring in place, and making sure that there's hyper clear ownership, which in my opinion is not the state of the world today. So a quick review on what we see the future of Chassis being and sort of where we are right now. We are in full swing of actually implementing these events. So we have an ERD done. We have the SDK that I've mentioned completed. Teams that are all this is actually one of Convoy's largest tech initiatives for 2021 and 2022. So we're swarming on this as an organization, and we've already rolled out a lot of events. Chassis is almost completed. So our goal is to have this finished by the end of Q4 of this year, and then have it ready for onboarding and adoption as teams begin to migrate to this new framework in Q1. And we really want to focus on the onboarding experience of Chassis, as we think it's going to be critical to getting both data science and product teams on board this brand new workflow of thinking about events and thinking about data. So my last one is a pitch. Like, if all this is exciting, please come work with us, because we do have open headcount. And that's it. We're done.